Okay, if you could do nothing else, I would hope you at least would notice that -5 and +4 are important spots and you put a dot there. Now, I hope you can do a lot more than that, but then I hope you could also say that the lead coefficient of this thing would be an x to the third. It would be this and this and this all put together, making this thing an x to the third kind. That means that one end's got to be up and one end's got to be down. They got to be opposite directions. Then the lead coefficient, there's no negative here, and therefore it has to mean it goes up on this end. Now, it's bouncing at this spot, so it had to bounce right there. Next, the y-intercept is where what? Some of you guys still aren't processing this. The y-intercept is not where it touches the y. The y-intercept is where x equals 0. So you stick a 0 in here, and you see where it turns out. That is a ridiculously big number. 0 or 5 times 4 squared is 16. 16 times 5, holy crap. It goes way, way, way up there, but I'm not going to check you if you're not going to have to graph it exactly. This needs to go through up there somewhere. And then these ends have to go opposite directions, right? So this other end must be going down here. How many of you sketched it right? Awesome. Then, where is this function less than or equal to 0? Well, that's a spot where it's equal to 0, so I hope you included 4. It's easy to forget that. And then this is another spot where it went below the line in there. So it's from -infinity until it hits -5. And it touches there, and at that moment, it is less than or equal to 0, so it satisfies it, so it's a bracket. Union with 4, and I don't care if you put parentheses or brackets around a single number, because I get the point. I personally like brackets because it feels like it's saying it works there, but I would accept parentheses around it. There's your answer. From -infinity to -5, it works because it's below in there. And here's a spot where it's equal to it, and that said or equal to. That's the other spot. There you go. Stuff. It's not that bad. All right. If you haven't already, find the file that says today's date on it, and I'll get there together. I'll pause. So here is the intermediate volume theorem and identify multiple zero behaviors. That's the whole bounce thing. And make a sign chart. All right. The sign chart is the last thing that we have to talk about. So here's one. This is a pretty intense one. It's a lot like what we just did as kind of like a warm-up to this, but we can generalize. You know the whole bounce thing? It's any even number will make it bounce. And any odd number will make it cross through the graph at that point, like a 1 or a 5. It will not bounce. It'll just pass through from the one side to the other. Now, you may remember when you learned this in higher algebra, we just made a distinction between a 1 and a 2 and a 3. This was cutting through simply. This was bouncing, and a 3 was doing the x to the third thing, where it kind of like changes direction at the spot where it crosses. For right now, we're lumping these two together as both odd things, and therefore they both just cross through, as opposed to a bounce, which would happen, boing, either bounces like this or it bounces like that. Okay, so now, if you had to do this one, don't let the fact that it's to the 5th freak you out. Just act like it's cutting through right there. So at 3, now, how am I supposed to do this? Let's say I make that 5. So that's 10. Okay. So then at +3, which would be right here, it's cutting through. I just don't know to which direction yet. At +6, it's bouncing. And at +9, cutting through again. There's the lead coefficient here would be a 5, 7, x to the 8th. That means that since it's even, that both ends are up. So it ends up like this, and over here, this end has to be going up. The only place it was going to bounce was right here. at the 6. But I'm not sure if it's bouncing this way. No, it's not going to be bouncing that way. It has to cut through here, it has to bounce here, and go back up through there. There we go. I could find out the y-intercept, but I know it's going to be some big positive number. In fact, it's going to be just ludicrously big because this is to the 5th, so I'd put in 0, and I get -3 to the 5th. Really big negative number. This would be another negative number. They multiply them together, make it positive. This is squared, so it has to be positive again, so it's going to be positive. So some really huge number for the y-intercept up there. All right, so what's the moral of the story? We're going to take these and then say, when was this function less than 0? When was this function, here, I'll make it red, less than 0? Would you answer that question for me? You can use my picture if you want. When was my function less than 0? Everybody write this one down. Pause for a second. Here we go. So you should have said that in this zone right here and in this zone right here it would work, but not all together. You can't just say from 3, there's a missing tick mark there, from 3 to 9, it just works that whole time. Because at this moment it hits 0, and I said it needed to be less than 0. So you should have said from 3 to 6, and it works at, or doesn't work at 3 because it's 0 there, and then we wanted less than 0, and it doesn't work at 6. It starts again working after 6 and goes until 9. From 3 to 6 and 6 to 9 with no brackets, because it never, the bracket would indicate that it's equal to. Every time you have a bracket, it means that you have an or equal to going on right there. Okay, that's about as intense as that would get. And let's actually jump into the homework at this point. So, oh wait, one question that's like, there's going to be some real world questions on your test, so when we hit them. Okay, so let's talk about a real world question. Everybody look at this one. This is actually U.S. postal regulations that the length plus the girth means around it. The length is the length of your box, and the girth is the distance all the way around the box. Okay, together they have to be less than or equal to 130 inches. That's their rules. If it follows that, they will ship it. If it is bigger than that, they won't ship it because it won't fit in their truck, basically. Okay, so that sounds like a less than or equal to kind of problem, right? Less than or equal to 108. There we go. And then apparently there's some sort of equation that I could probably write for this. And would you guess it's probably something like this? Because of the context of what we've been doing lately. And it probably has to do with one of those is for length and one of those is for like this distance. And apparently this particular package has an X in both of those spots. And actually, I believe this is length plus girth, and so therefore it's the length, which I can call L, plus the girth. And the girth I know because I've got this part. Don't say x squared. What's the girth? The distance all the way around the box. 4x. X plus x plus x plus x. 4x. The girth is 4x. And that leaves me only with the length left. All right. Now it says express the length of the box in terms of x. Whew, there, I got length. They just want me to solve it for the length then. If you want length in terms of x, if I want to solve this for the length, I just have to subtract 4x from both sides. I got length less than or equal to 108 minus 4x. That is the length, L, in terms of x. Has an x in it. All right, so there's some themes with these type of questions. They always start with a formula, and it's right there. And then I just have to fill in, instead of length, I got to put a variable for that. And instead of girth, I got to put a variable for that. And then a lot of times these are going to be inequalities, so I'm going to say like this part, less than or equal to 108. All right, so that's just a, kind of an outline, but these are the type of questions that you're going to encounter on your test, so I wanted to just talk you through one of them before we entered the homework zone. All right, I'm going to pause for... Okay, I found it. This is the lead slide for the homework for today. So, do we have to do those really advanced ones that we were just doing together? Not unless it says to. So let's read the directions here. Mr. DC, would you read for us what we're supposed to do? Starting with find. Multiplicities. All right. All right. Does this one say less than or equal to? No. That means we just have to sketch it. We don't have to like figure out where it's above the line or below the line. So, all right, so let's make a sketch. And the multiplicities part, by the way, I never used that word. That's the powers. Remember how if it's a 2, it's a bounce, and if it's a 1, it's a cut through? All right, CB. Take it over from there. Tell me some important points on this graph that we're about to make. Yep. That tells me 2 and -1. Excellent. There's a 2 dot. There's a -1 dot. Tell me more about the actual graph, like where this going to be up and down and that kind of stuff. The right side's got to be down, so you could start by putting a little like tag in down there. I know it's going down, and that means when it comes out of this, it has to be going down. Tell me more. It's going to be bouncing at the 2 on the right side. Very good. So if it's coming out of this going down, it was bouncing off of that. Awesome. Tell me more. It'd be handy to know if the y-intercept was right now. Yep, sticking in 0 for x. And I got -2 times -2 squared times 1. Timesing by 1 doesn't really do anything. So then, ballpark, well, not ballpark, exactly, what is the y-intercept? -8. All right, now I don't have to have it exactly at -8, you know what I mean? But I know it's down here somewhere. Okay? So I'm going through there, and now what? All right. I'm going to go back up through that. How do you know it goes through it? Because of the multiplicity. This little number right there was a 1. If it's odd number, it's going to go through it. If it's an even number, it's going to bounce off of it. Okay, cool. There, we got our picture. And now, did it ask me to like actually take this and say where it's above 0 or below 0? No, this didn't ask that. Okay, that would be near the end when you're doing more complicated ones. If they had said this whole thing is greater than or equal to 0, you'd go, oh, in this zone, and that's a spot where it's equal to 0. Okay, that would be the more advanced version. All right, cool. And we did that one together. That is part of your homework. We're also doing this and this. On this one, if you're going to solve this equation, I had one yesterday where I just said to clear the fraction. Do you get multiplying by x would not clear this fraction situation, but multiplying by what would? I only got 2 choices, x or x squared. So do you get why multiplying by x squared would actually fix both of them? Could you get the door for us again, please? Thank you. Multiplying by x squared would fix both of them. If you have forgotten how this works, we have to multiply everything by x squared. That'll clear our denominators. And the mystery isn't, I mean, obviously x squared will cancel x squared, duh. But why will it work here? Because x squared one of the x's can go down and cancel this other x. So this part right here, the squared part will be gone. It won't be x squared anymore. It'll be just an x, and that'll cancel this x. You get now I end up with that x to the fourth plus 7x squared equals x to the third minus x plus 8. Pretty intense, and I'm not done yet. Because now I have to get everything over to one side. Personally, I'd probably move all this stuff over here because I want my lead coefficient to be positive. And if I do it this way and get them all to come over to the left side, my biggest power is this x to the fourth here, and I want it to be positive. Because then I don't have to worry about it going down on the right. So this is x to the fourth. When I bring this x to the third over, it'll be negative x to the third plus 7x squared was over already on the left side plus x minus 8 equals 0. Now, believe it or not, you actually factored things like that a long time ago, back when you were in higher algebra, but it's been a long time, and I'm not going to try to tackle that today. If you've got it to this point, you're close. Do you get, if you could break it up into something like this? That would help you to get it to look like the other questions. Okay. But I feel like I'd be trying to cram too much into today if I try to teach you how to do that. So we'll leave 7b at this point. We'll see if we can do more factoring like that later. It involves synthetic division. Does that ring a bell? Synthetic? Where you go like this. It's been a while since you've done that, but anyway, don't worry about it for right now. Move on to this one. When it says one solution is x equals negative 3, do you get that that means that this part factors and one of the factors must be, you know where I'm going with this? One of the factors has to be what? If the answer is x equals negative 3, one of them has to be x plus 3. Awesome. Now, you're likely to just get stumped right there then. And that's where, and I'm not sure if we're ready to bring in the big factoring guns here. Are we ready to do synthetic? I need to think about that before I assign that. So I'm not going to assign 9 or 10. You may skip these for now. And this one is a regression question, except it is not linear regression, it's cubic regression and quartic regression. I think that would be good for you to see. It's just entering that data on the calculator, and then instead of sitting linreg, right underneath it is quadreg, and I hope quartreg is the next one underneath that. All right, let me see what. Ah, that one's pretty intense. Not going to sign it. Too intense. All right, this one I talked through with you. I talked to you at the beginning of it through with you. This one is doable. I hope you respect the fact that I am being reasonable about what I'm assigning here. You can do that. It won't be fun, but I've already given you the outline of it, and that's doable. That's the one where, again, I don't want to review it. If you want to review, you can go back and watch the video. It's the one where we set it up and said that it had to be less than or equal to 108. This part. and we knew the girth was the distance around here, all the way around. So it was 4x. Okay. All right. So that one's assigned. Skip. That one I wanted you to do with me to just get it factored, and we'll talk more about how do we handle those hardcore factoring ones. And these 3, and that's very doable. Okay. Any last questions? All right. Now we're actually a little bit ahead on the, there's going to be some coming where we have to do the greater than or equal to or less than or equal to kind of questions. But we're a little bit behind on the hardcore factoring stuff, so I'll pick that up tomorrow and talk more about how do you do the factoring of these great big scary looking things. All right, that's all I got for the video for today.